We will continue to explore the description and analysis of the thermal reaction norm of 6 ratio, mainly for reptiles and with an example about turtles. The first part, the first video, was about what kind of model we should use. The second video was a practical video about how to estimate the parameters of my thermal reaction norm. The third video was about the comparison of thermal reaction norms, and we have used here the thermal reaction norm of the Olive Ridley, and the data have been obtained in 3 different RMUs, and we test if there is an RMU effect. Remember, we use R within RStudio with the package Embryo Growth. Now we will use another package, and we use within the package Embryo Growth a database TSD, which is a database of sex ratio obtained at constant incubation temperature for turtles. So, in the third video, we have described an RMU effect of the thermal reaction norm. All the data came from the same species, but we split the data by the origin, the RMU origin of the females, and we describe the thermal reaction norm for the 3 different RMUs. Then we have 3 different set of parameters S, L, S, H, and P for the 3 geographical parts of this species. Then we add 9 parameters to describe the diversity of the answer of thermal reaction norm of sex ratio. Then we have tested if we need this RMU effect or not. When you are doing this, you consider that RMU is a fixed effect. So an alternative is to consider RMU as a random effect. This term fixed and random needs some explanation. This is what I will do now. A fixed or a random effect. First, this effect applies only to categorical factors. They can be either fixed or random. The difference between a fixed or random effect is quasi-philosophical. This subject is discussed regularly in scientific literature, and there is no clear consensus. For some, all categorical effects should be random effect, whereas for others, random effect should be the exception. To understand the discussion, we need to describe in our specific context what are the consequences of fixed or random effect for RMU. If RMU is added as a fixed effect, it supposes that the outputs within one RMU follow one single model, one P, one SL, one SH value, and the variance come from the sampling procedure within the RMU. If the RMU is added as random effect, it supposes that you have a global model for the species, so one P, one SL, one SH value, and each RMU has its own effect obtained as variance for each parameter. Let's write this with equations. Sometimes equations are more easy to understand than word description. if you don't have RMU effect. The number of males and number of females for a G experiment is based on the sex ratio model for the temperature G with the parameters P, SL, and SH, which are the parameter for the species, plus an error that is due to the sampling because M and F are limited numbers, they are not infinite. If you treat RMU as a fixed effect, you will have 9 parameters. That is what we have done in the previous video. So for each RMU, we have a different model. So we have 3 sets of P, SL, and SH, then a total 9 parameters. Now, if the RMU E is treated as random effect, you have one global model for the species. This is the first line. For the species, you have one global model, but for each parameter P, SL, and SH, the specific value is obtained from distribution. This is the 3 last lines. P for the RMU E P for the RMU high is obtained from distribution with the P of the species and some dispersion parameter. SL for the RMU high is obtained from distribution with SL and a parameter describing the distribution of the SL values, and the same for SH. In this case, we have only 6 parameters. The 3 central parameters P, SL, and SH, which are the parameter for the species, and the parameter here sigma, which describe the dispersion of the possible values for different RMUs. Let's see how we can implement this in our specific case. Remember, we are in olive ridley, marine turtles, and we fit the model for 3 different RMUs. We must use a new statistical tool, which is STAN. STAN is a statistical language available in R with a brms package. We define the prior. Here, the prior for P is a normal distribution in average 30 and standard deviation 5. The prior for SL and SH are uniform distribution with value from 0 to 12 because we don't know what this parameter can have as value. We run the model. I give you the code in description, and now look at the results. For each panel of 2 vignettes, you have 1 parameter, and so you have 6 couples or vignettes, the 6 parameters of the random effect model for RMU. The left are the central value for the population. So we have the distribution of the values at the scale of the species. We have P, SL, SH, and at the right, you have the standard error of the distribution of each parameter at the scale of the 3 different RMUs. Let's see what results we obtained. We obtained thermal reaction norm pattern with flexit double star model for East Pacific, Northeast Indian, and West Atlantic RMUs. Now, the question is, what is the best description of RMU effect, random or fixed effect? To test if RMU should be treated as random or fixed effect, we use WIC and WIC weight, and we conclude that the models are very similar. In this particular case, we cannot really distinguish between RMU as random effect or RMU as a fixed effect. Random effect is slightly favored, but based on IKK weight, we cannot really conclude. Just it has less number of parameters, 6 versus 9, and in a concept of optimization, we prefer a model with less number of parameters when the models are similar. So we could prefer random effect for RMU, but honestly, we cannot conclude. On the other hand, we can conclude about RMU as random, fixed, or no RMU effect. Then we test the three models, fixed effect, random effect, and global no RMU effect, and we conclude again, as in the previous video, we conclude again that RMU effect is not at all favored. The selected model is without an effect of RMU, then a global model for this species could be sufficient. In conclusion, we test if the RMU effect should be included as a fixed or random effect. For this particular case, we cannot conclude. They are similar. But we conclude that RMU effect include as random or fixed effect is always counter-selected as a comparison with no RMU effect. Always, I remember, this pattern should not be used to estimate sex ratio from the field. It will be the next video where I will begin to explain in the field how you can estimate sex ratio. Thanks.